All right, welcome back. So we've talked about graphing cubic functions, and today we're going to talk about graphing quartic functions. So we're going to do the same basic thing, but we're going to do it with a quartic. Remember, a quartic is to the fourth power. And we're going to find all those wonderful things again. So the first thing we're going to do is go ahead and type that function into our calculator. Again, I've got negative x to the fourth plus 5x squared minus 4 as my function. I'm going to go ahead and hit graph so I can see what that function looks like. And there we have it. You may want to expand this out a little bit. We can change our windows a little bit. We don't need to necessarily see all of the x values or the y values there. So I'm going to go ahead and change this. Maybe our x min being a negative 7, x max being a 7, and then maybe negative 10 to maybe 10 in this case. So now if I graph that, that might be a little easier for us to see. We're really interested, though, in what our domain and our range and all these wonderful things are. We'll get more specific as we find these values. So, domain. What do we know about our domain? Domain is the x values. So if I notice here, this function, this graph, it's continuing to go down, and it's working its way out as well. And then this side is working its way out. So I see that my domain is negative infinity to infinity. My range, notice we start down here at negative infinity, but I'm going to work my way up. It looks like maybe these are the same height. I would say they probably are. So how can we find those 2 points? Well, they look like maximum values, don't they? And they're relative maxes because they're at this high point here just in that region. Remember, relativity means in that region. Now, if we find that it's an absolute, or it is the highest possible point at all, then it would be called the absolute max. And we're going to have an absolute max within one of these, but both of them could be our max. So to find that, we're going to go ahead and second trace, and we're looking at that maximum value, number 4. Again, we can move that cursor to the left by using that left arrow, or we can type in a number. All we have to do is be to the left of that high point, and then we're going to come back and go to the left, or to the right of that high point, and then hit enter. So we have a maximum value here at negative 1.581, the x value, and our y value is 2 1/4. So I'm going to come down here off to the side, just write that down for a second, so that we have what that value is, because I want to check this other value as well to see what that maximum point is. So I'm going to do second trace, my maximum again. This time, this one looks like it's between 1 and 2, so I'm going to do a left bound of 1 and a right bound of 2. Hit enter. Well, would you look at that? It is symmetric. We have 1.581, and we have that y value of 2.25. So our maximum, we have an absolute maximum in this case, and this absolute maximum is going to occur at negative 1.581, 2 1/4, and at 1.581 again. Remember, we're going to 3 decimal places as we do these, 2 1/4. Now, if it doesn't have a third decimal place, we don't have to write the 0 in this case. We just leave it as 2.25. So while we're doing that, we can also pull in this range then. So our range is from negative infinity all the way up to this highest point, which in this case we have these 2 high points. So our range is going to be negative infinity to 2 1/4, and it's going to be an inclusive, so we use that bracket because we can touch that 2 1/4. Our end behavior, notice the 2 sides of this, they're both going to be pointing down, so our end behavior is going to be down, down. Our solutions, zeros and roots. Again, we're looking, where do we cross the x-axis here? Well, I can go ahead, do my second trace. I can do a 0. Again, we can either type in a number or we can move that cursor. It looks like it's going to be at about negative 1.5, or sorry, negative 2. So I'm going to go ahead and type in negative 3. That gives me to the left. To the right, I can't type in 1 because it looks like 1 is a 0. So I have to be somewhere between 1 and 2, or negative 1 and 2. So how about negative 1.5? That gives us that point there. And then it looks like a 0 is at x equals negative 2. We can go ahead and find this point doing the same thing. We're going to do second trace, our 0. Again, I'm going to try that -1.5 for my left bound. And my right bound, I can type in 0. Hitting enter. It's going to think a little bit, isn't it? Oh, there it goes. So -1 is going to work for me. We're going to come over here. Again, this looks like 1. So we're going to go ahead and do our 0. Again, I'm going to type in 0 and then 1.5. Hitting enter. Oh, guess. Yep. And then we have x equals 1. And then last but not least, it looks like we have 2, doesn't it? So our 2, there's 0, so we're going to type in 1.5. We're going to go to 3. For our right bound, we're going to guess, hit enter, and we get 2. So we do get the solutions of -2, -1, 1, and 2. Again, those are our roots and our zeros. We can go ahead and find that minimum value. So looking at this minimum value, again, just in this region we have a minimum value, don't we? So we call this one a relative minimum. So that relative minimum, we can do second trace. We can do our minimum, number 3. Again, we can type in a number. We can type in, how about -1? And to the right, we can type in 1. Hit enter, and that gives us a relative minimum at negative. Now again, look at that, interesting. -2.277 e to the -6. We talked about that yesterday, or when we were talking about graphing our cubics. Remember that e to the -6 means times 10 to that power. So that's going to be a very small number. So that's going to be pretty close to 0. And our y value is going to be -4. So that's going to be our relative minimum value. So now let's talk about our increasing and decreasing intervals. So we're increasing. Again, we're talking about the x values, -infinity, all the way to this point here, that x value. And remember, that's also part of that maximum. So our increasing interval is -infinity to that -1.581. But we also have an increasing interval from this point, which was x equals 0, to this x value. So we have 0, 2, and that went from 1.581. Again, that's going to be in parentheses. Kind of crunchy there. It's 1.581 is our value. Decreasing intervals. And we're decreasing from this point to this point. So our x values are going to be that point, -1.581 to 0. -1.581 to 0. And we're also going to have a decreasing interval from this point all the way out to -infinity, or positive infinity on the x-axis. So that's going to be our 1.581 to infinity. And if you recall from yesterday, as we were talking about our increasing and decreasing intervals, I should be able to go from -infinity to infinity by going from an increasing to a decreasing and on through. All my numbers should line up so that I can do a continuation all the way to infinity. So I get -infinity, -1.581, -1.581 to 0, 0 to 1.581, 1.581 to infinity. So you should always be able to check your increasing and decreasing intervals for this function. So that gives you an idea of what our quartic functions are going to look like. Now we did not talk yesterday about the cubics where we had that negative and a positive. Notice that negative, a value, leading coefficient, our function was turned upside down, or it opened down and down. What happens if it was a positive value? So I go to my y equals, and I'm just going to go ahead and delete that negative value. Now if I graph this function, take a little bit of time here. So notice what happened. It turned it so that our end behavior was an up and an up. So it flips the way this graph is going to look. It also changed quite a bit of other stuff within our domain range and our zeros. But more importantly, I want you to see that it's going to flip it so that it ends up and up. All right. So that gives you an idea of graphing our quartics using our graphing calculator. Good luck. Enjoy. If you have any questions, let me know.